This video takes what you learned about in the first video just a little step further. The process of integration remains the same, but you're going to learn key notation to do with integration. And the reason you're going to learn this is because all mathematicians of a certain level understand what is meant by certain notation, so we have to learn it. So make sure you've written the title and you're clear about the learning objective. And what I want to show you is, like in the last video, we looked at a situation where dy by dx, we were told, was equal to, let's say, 3x squared, and you were asked to find y. So just make sure you're clear about that. Pause the video so you've got time to do it. And hopefully, well, you thought to yourself, you set it out over here, and you say the power is 2. So that means the original power must have been 3. When we differentiate that as it is, we get 3x squared, which is actually perfect. It's what we wanted. So therefore, y is equal to x cubed. Now, a different way of asking this same question, what is the function y if dy by dx is 3x squared, is to write it like this. So this elongated s, this means integrate. This is obviously the expression you're going to integrate. And dx means with respect to x, which basically means it is the power of x that you need to be concerned with. So that's all that this video is really about. We're going to do some slightly harder examples than we did in the first video, but make sure you've written down what this key notation means. The answer will still look the same, but you won't need to call it y. All you need to say is that this is equal to, and then you write your answer. You don't need to call it y. So that's it. So make sure you've written your notes and then press play when you're ready to keep watching. So we're going to look at question A first of all. And you can see we're being asked to integrate this expression here with respect to x. So what that means is we're going to write out our integral like that. And for the time being, I want you to still be in the habit of writing it down here, being ready to write your answer up here, and writing your working just to the side on the right. So if the integral is this, the original expression focuses first of all on the power of a half. I know that the original expression must have been x to the power of 3 over 2 in order to differentiate to give x to the power of a half. We're going to come back to the constant after we've dealt with this power and this term over here. So for that 2x to the power of 3, I know that it must have been x to the power of 4 originally, because that differentiates to 4x to the power of 3. And that's got the same power that I'm aiming for. Now it's all about figuring out what we need to times both of these terms by in order to give them the same coefficients as we have over here. So what do I times 3 over 2 by to make it equal to 1? Well, I just times it by the reciprocal. What do I times 4 by to make it into 2? I times it by a half. So that means I'm going to be timesing this by 2 over 3 and this by 1 over 2. The answer is going to be therefore 2/3 x to the 3 over 2 plus a half x to the 4 plus c. Because this type of integration is called indefinite integration. And what that essentially means is we're not clear about what this c value is. There's not a precise value for the original function. for the original expression. So that's what this is, indefinite integration. And if you look in the textbook, that is what the title of this part of the chapter is about. So make sure that you've written down any notes that you need to. And then I want you to have a go at questions B, C, and D on your own. Right, so let's go through these quite quickly. So we've got B, the integral that we're dealing with is this, which means, first of all, I'm focusing on that. One above that is x to the negative a half, and when we differentiate that, we get negative a half x to the negative 3 over 2. There is no x term here, which is basically x to the 0, because that is the same as 1. So 1 above that is x to the 1, and that obviously differentiates to 1. So now it's about figuring out what we need the coefficients to be. Coefficient over here is 1, so therefore I'm going to times this by negative 2, because negative 2 times negative a half is positive 1. The coefficient here is 2, so I'm going to multiply this by 2. So my answer is going to be negative 2x to the negative a half plus 2x plus c. That's my answer for B. Make it really clear, that is the answer. All the rest is just working out. Do question C over here. I'm being asked to integrate the expression p squared x to the negative 2 plus q with respect to x. Again, I'm going to focus on the x powers, and there's no x here, so it's x to the power of 0. So these are what I'm focusing on first of all. X to the negative 1 is 1 above negative 2. That differentiates to negative x to the negative 2. X to the, zoom out a bit, x to the 1 is 1 above x to the 0, and that differentiates to 1. Now it's about figuring out what the coefficients are. So I've got a positive p squared as a coefficient here, which means I need to times this by negative p squared, because negative p squared times negative 1, positive p squared. I've got just a q here, so I'm going to times 1 by q, positive q, and that gives me that. So negative p squared x to the negative 1 plus q x plus c, that is my answer. Finally, question D. This time I'm being asked to integrate the expression 4t squared plus 6 with respect to t. So that means it's the powers of t that I'm concerned about, and there's a power of 2, and remember if there's no t, it's the same as t to the power of 0. So I'm going to integrate that. So 1 above 2 is 3, that differentiates to 3t squared. That's that, which differentiates to 1. I'm aiming for a 4 here, and at the moment I've got a 3. So what do I times 3 by to make 4? Well, I times it by 4 over 3, because then the 3's are going to cancel. I've got a 6 over here, which means I multiply the 1 by 6, so that's what I'm multiplying up here, and it's positive. So my answer is 4 over 3 t cubed plus 6t plus c. So if you got those right, give yourself a tick in purple pen. To be honest, it's nothing new apart from the notation, so if you were happy with exercise 13a, then this should have been no problem at all. Pause the video, make any notes that you need to, and then we'll go through the second example. So looking at example number 5, can you see what's different about all of them? There's something that's slightly different about the questions that compared to the questions that we've done so far that makes these examples a little bit more challenging. Can you see it? It's the fact that I've got x's as denominators and I've got root x's. So when there's an x term as a denominator or a root x, I have to get it onto one line and make my root signs indices. You have to get it onto one line, which means eliminate the denominators by writing them as negative powers. And I have to make my root signs into indices. So this is what you have to do. Make a note of it. So let's go to question A first of all. Let's rewrite A, the integral of A, so that it's nicer. But actually, you have a go at it first. Pause the video and do that, and then check your answers. I want you to do all of A, B, and C. I want you to write them all on one line and change all the root signs to indices. Press play when you're ready for me to go through it. So A is 2x to the negative 3 minus 3x to the half. And we're integrating that with respect to x. So that's what you should have written for A. B, we're going to expand it. So we've got the integral of x cubed, and then the x and the x cancel each other out. So we've got plus 2. And again, we're differentiating with respect to x. Part C, it's the integral of 2x squared, which is 4x squared, because remember the index number applies to both of these. And then I'm going to write x to the negative 2, which is this part here, times by x to the half plus 5, and all of that we're differentiating with respect to x. But I need to simplify that further because I can't have these terms like this. I need to have individual terms. If you didn't know that, you need to make a purple pen note saying you need individual terms, not terms being multiplied together like we have with the bracketed expressions and the bracketed expression and the number outside it. Always expand the brackets first when you're integrating. So that's going to be 4x squared. Negative 2 plus a half is plus x to the negative 3 over 2. And we've got the plus 5x to the negative 2 with respect to x. So now that I've got all of these onto one line, and I've changed all the root signs to indices, now I'm in a place where I can actually differentiate these expressions. Sorry, integrate these expressions. So I want you to pause the video and have a go at integrating each of A, B, and C using this, this, and this. Press play when you're ready for me to go through it. All right, so I'll do all this in, I'll do it in black pen. I'll show my working in red like I have been so far. So this time we're integrating 2x to the negative 3 minus 3x to the half with respect to x. I'm looking at the powers first of all, and I'm saying the first one needs to be x to the negative 2, which differentiates to negative 2x to the negative 3. And the second one has got to be x to the 3 over 2, which differentiates to 3 over 2 x to the half. Now I need to get positive 2 as the coefficient of this first term, so I'm going to times it by negative 1, because negative 1 times negative 2 is positive 2. And to get negative 3, I need to times this by negative 2, because that will cancel the 2's, and then I get a negative 3 there. So therefore my answer is going to be 2x to the negative 2 minus 2x to the 3 over 2 plus c. So if you got that right, give it a tick. If you need to make any purple pen notes, then do that now. Next, we're going to do B. We'll do over here. So we've got x cubed plus 2 that we're integrating with respect to x. So the aim over time is that actually you get to a stage where you don't need to write all the working out over here, and you can actually just integrate it in your head. So I'm just going to model that for this question B here, just so you can see what that looks like. And if you want to try doing it yourself, then I encourage you to do it. Obviously, if you start to make mistakes, then you need to keep the writing out over at the side, like I've done for all the other examples. So I know that if my original expression differentiated to give x to the power of 3, then originally it would have been x to the power of 4. When I differentiate x to the power of 4, I get 4x cubed. I don't want 4x cubed, I want 1x cubed, which means I need a quarter of x to the power of 4 in order to get this. If you want to check that, you can do it now. Similarly, I know that 2x differentiates to 2, and so I've done it in my head. So if you're able to do that and get it right, then I encourage you to do that, because it will obviously save you a lot of time. But if you're making mistakes, then make sure you're writing out all this working out like I've been doing over here. This stuff will eventually lead to this. For part C, the integral is 4x squared plus x to the negative 3 over 2 plus 5x to the negative 2 with respect to x. We're integrating it with respect to x. So I'm going to write my working out for this one because it's a bit more tricky. I'm focusing on these powers. I'm saying to myself, it must be x to the power of 3 originally, because that differentiates to 3x squared. It also must have been x to the power of negative a half originally, because that differentiates to negative a half x to the negative 3 over 2. And it must have been x to the negative 1 originally, because that differentiates to negative x to the negative 2. So you can see my powers are what I was aiming for. Now it's about figuring out the constants. What do I times 3 by to make it into 4? I times it by 4 over 3. So that means this is going to be 4 over 3. What do I times negative a half by to make positive 1? I times it by negative 2, because they'll then cancel. Finally, what do I times this negative 1 by in order to make positive 5? Times it by negative 5. So my answer is 4 over 3 x cubed minus 2x to the negative a half minus 5x to the negative 1 plus c. So those are the examples for exercise 13b. You might find sometimes that the answers, like for example this one, they might write the negative powers like this. Obviously we know that those are the same things, so if you're checking your work and you see that you've written them like this, the answers are showing them like this, just make sure that they're the same thing, and then obviously they're correct.